Okay, simplifying radicals. A radical expression is one that contains a square root. Sort of. Square root is what we use all the time. We'll talk about the other ones. This is a radical symbol. That doesn't have a number. And when it doesn't have a number, we generally assume it's a square root. The number or expression contained inside, you won't be quiz on vocabulary, but that's called a radicand. So that's what's inside. The number outside is called the index. And that's the number that goes right up here. So when there's no index, we call it square root. Otherwise, they don't write it, but there's a little 2 there, a cube root has a 3 there, and a fourth root has a 4 there. And obviously we have a 5th root and a 6th root, and so on and so forth. Okay, the radical expression is in simplified form. When all the following are true. The number under the radical sign has no perfect square factors other than 1. So you can't have a square root number trapped inside of it. The radicand does not contain a fraction, and so you don't want a fraction underneath the radical. And no radicals appear in the denominator. Okay, so we're going to write out the perfect squares up to 400. So that's 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. 121, 144, 169, 196, 225, 246, 289, 324, 361, and 400. All right. The product property is used when simplifying radicals. It allows you to take the square root of product of numbers and break it up. So you can take this and break it up into this. You can separate it. So you could break this up into, the square root of 25 times the square root of 4. Now, we already know the square root of 100 is 10. I know that. But you could write it like that and just see that it is broken up by multiplication. Same thing with, the square root of 18. You could break that up into the square root of 9 and the square root of 2. You can also break it up into the square root of 6 and the square root of 3. Now, 18 is very important. Notice I can break it up 2 different ways. 9, 2, 6, and 3. The 6 and 3 doesn't help me at all. Okay? 6 is not a perfect square. It's not on that list I just gave you. And 3 is not a perfect square. But 9 is, right? 9 is a perfect square. So what you're doing is you're looking at these numbers underneath the radical, and you're trying to find out, are there any perfect squares that go into 18 or 12 or 32? That's your goal. So 12. I know I can break it up into 6 and 2. But 6 is not a perfect square, and neither is 2. Is there a number on that list that goes into 12?
Yes.
What? 4. Now, I suggest you get in the habit of writing that perfect number first, and write the other one second. So instead of writing radical 3 times radical 4, write radical 4 times radical 3. Because this is going to become 2 radical 3. Now, it's not saying you can't write radical 3 times 2, but just be in the habit of putting that perfect one first. So up here, we talked about 6 and 3 won't help us, but 9 and 2 will. What's square root of 9? 3. So our answer is 3 radical 2, or 3 times radical 2. You don't have to put that dot there, but that is multiplication. 32. I could do I have 2 choices here. I can do 4 times 8. I can do 16 times 2. Now, they're both right, and they both have perfect squares. But if I do 4 and 8, I'm going to have to do it again. Because the 8 has a 4 inside of it, right? 4 times 2. So it's like a factor tree. You have to break this down again and do it all over again. You want to be the most efficient as possible. So what I tell people is, when you're looking at this list, okay, and for this test, you'll get a lot of use that piece of paper that has all these on here. I suggest you start backwards. So if we're looking at 32, obviously 36 is too big. We're going to start right here. Well, obviously 25 doesn't belong to 32, but 16 does. Eventually you get to 4, but start at the high end, not the front end. Because otherwise you'll say, hey, I simplified it, but there might be a number still inside of it. So I'm going to use the 16 root 2, which will give me 4 root 2. I want to get there quick as possible. Okay, 45. 9 and 5. Now, I could also do 15 and 3, but 15 is not a perfect square, and neither is 3, so that doesn't help me. Okay, so 54. I could break it down 27 times 2. It's not, neither one of those is a perfect square. So I want to do 9 and 6. So again, 9 is the perfect square. Oh, I'm sorry. I forgot this one. This reduces to 3 radical 5. 121, that's on the list, isn't it? That's just straight up 11. You're done. There's no radical. It is a perfect square. Do not do this. That is not the answer. Okay, the radical goes away. Don't leave the radical. You might want to write that down with slash to it, because people do that all the time. Okay, you're taking the square root of 121 out, and the whole thing comes out. Okay, 44 breaks down to 4 and 11. And just simply 2 radical 11. 2 square root of 11. Now, 147 is not going to jump off the page at you. You might have known 9 times 5 and 9 times 6 in your timetables. You might even know that 121 is a perfect square. But 147, you are going to probably have to take your calculator and do a little bit of work. But again, it's not that bad. Okay? We're looking at 147. Well, that means you're starting here and working backwards. Obviously, you're not going to type in the calculator 147 divided by 144. You're not going to divide by 121 or 100. Probably not even 81, because you should know that's 160 something. 8 and 8 is 16. So maybe you start at 64. And you type in your calculator 147 divided by 64. And you get a decimal. Okay, move on to the next one. 147 divided by 49. And you get 3. So it doesn't take very long. It's not a lot of work. You have a calculator. This is radical 49 and radical 3. The square root of 49 simplifies just to 7. So 7 radical 3. 175 should be pretty easy. It's just a bunch of quarters in your pocket. 7 of them. If you have 7 quarters, you have $1.75. Square root of 25 is 5. Simplify. Okay, if there's a negative sign outside, that's the second step. Just look at it as the square root of 81, which is 9. And then it's just simply that. The opposite of opposite of 9. Negative 9. Now, this is not saying negative 9 times negative 9 is 81, which it is. That's not what it's saying. This is taking the opposite of whatever comes out. Now, what came out was 9. So our answer is negative 9. Kind of like when we did absolute values. Okay, so remember, when we did absolute values, we'd have like the absolute value of 7 was 7. The absolute value of negative 7 was also 7. But if I throw a negative out here, then my answer is negative 7. Because the negative outside is saying take the opposite of whatever you got. We can't do these. Okay? There's no real solution. We don't know how to deal with this yet. When you get to Algebra 2, you'll learn how to deal with these. It's called imaginary numbers. I'm giving you a 2-year foretelling of what's to come, foreshadowing. You'll deal with imaginary numbers in Algebra 2, but not yet. Right now, we just say no real solution. Because there is no number times itself that gives you a negative number. The only way to get a negative number is negative times a positive, which is not the definition of a square root. Okay. So here's some common ones that simplify. So I'm not going to show the work. Well, yes, I'm. So this is 4 and 3. That's 2 root 3. These are ones you'll see a lot of. This is 9 and 2. So 3 root 2. This one is 4 and 5. So 2 root 5. 16 and 2. So 4 root 2. 9 and 5. 3 root 5. And then this one is very popular also. 16 and 3. So 4 root 3. There's nothing to do here. These are ones that don't simplify. These numbers won't break down. Yes, 15 is 5 times 3. None of those are perfect squares. 30, 6 times 5, 10 times 3, not perfect squares. 21, 7 times 3, not perfect squares. Okay, so none of these simplify. You would just leave them as they are. Nothing to do here. Move along.